Right. Then we start this discussion. Okay. Question number one. Go to exploration question. Yes. We are given first question. Go to exploration. Right. First, we'll do the diagram. This way we have the wedge. Okay. We have the plane. Here we have a pulley. Here we have another pulley. Here we have another movable pulley. Right. Over this pulley, another string is passing like this. Okay. Right. Masses attached like this. 3m. Here m. This is 2m. No? Then here weight 2mg. This has the weight mg. This is 3mg. This is R. This is S. This subject is Q. Right. This point is B. This is C. Angle this is alpha. Over this pulley stream passes now. This way. Right. Mass of the wedge is 5m. Here mass is 4m. Therefore weight is 4mg. Right. This is a okay, no? Yeah. Pulley of Q of mass 2m. Okay. Mass P of mass 4m. And Rn is Mn 3m. Okay. Now we can mark the tensions. This string and this string are different strings, therefore different tensions we have. Then I'll take this as T1 tension. This also therefore T1. Here T1. Here T1. The tension in this should be a different tension. Suppose T2. This way T2. This way T2. This way T2. This way T2. Right? Okay. Now at time t equals T only we draw this diagram. So more forces there available to mark here. Normal reaction coming to this S, it is perpendicular to the plane. For this normal reaction coming R, perpendicular to this horizontal plane. This is the moment T equals T. T equals T moment is this. Okay. Right. Now, you know, when this Q does not move, this is heavier one. When this moves down, this moves up with the same acceleration relative to this Q. So therefore, I'll take it as F. What is this F? Acceleration of S relative to Q. Then this should move upwards with same acceleration F. Okay. Now, I can take the distance as this way. At time t equals t, I can measure the distance from this fixed position. This is fixed point. From this fixed point to this movable, this moving, which I can measure the distance as x. Then acceleration is x double dot. Right. And here, at time t, I can measure distance to this. Let us take this as y. At time t, y means the acceleration is y double dot. Right. This x has been measured from a stationary point in the earth. Therefore, this x double dot is the acceleration of this wedge relative to earth. But this y is distance to this 4m from a point on the wedge. Therefore, this y double dot is the acceleration of this particle, right, relative to wedge. Relative to wedge. Okay. Okay, P here. This particle is P. And also, we can measure the distance, this. What distance? This. Let us take this distance as Z. Then the acceleration of this Q going to be Z double dot. Q has the acceleration Z double dot. This Z also we have measured from a fixed point on the earth. Then this Z double dot is the acceleration of this Q relative to earth. X double dot acceleration of this wedge relative to earth. Y double dot is the acceleration of this particle P relative to wedge. Okay. Right. Now we can write first term this way. Acceleration of Q relative to earth downward is a double dot. Next one, acceleration of R. Okay, R. R relative to earth. What is that? If this Q is at rest, this R moves with acceleration F upwards. Once this Q moves with this acceleration is a double dot, this will get it automatically. So then this R will have downward direction is a double dot, upward F. So therefore, in the upwards direction, the acceleration of R going to be F minus is a double dot. Okay. Acceleration of the wedge, 5m, relative to earth, x double dot, right? You might say, really, the wedge is moving leftward. Why did we mark this x double dot rightward? Never mind. Finally, in the calculation, the x double dot answer will be negative. Therefore, we never worry about that. Huh? Okay. And the acceleration of S relative to earth. S means this object. Okay. It is going, if n is a double dot both downward direction, F plus is a double dot. Okay. Then acceleration of P, the last. Acceleration of P relative to Earth. When this wedge doesn't move, the particle P descends this way with acceleration y double dot. Meantime, if this wedge moves, that acceleration of wedge x double dot, this particle P will get. Then it will have the accelerations like this. This way, x double dot. This way, y double dot. This angle is alpha. Okay. When the system is released from rest with all the strings taut, then write down equations sufficient to determine the acceleration of the particles and tension in the strings. Right. How many unknowns are there? Yes. T1, T2. X double dot, Y double dot, Z double dot. Right? And if, correct, no? T1, T2, X double dot, Y double dot, Z double dot, and simple if. There are 6 unknowns. Then we must write 6 equations. Right. Let's see how to write the 6 equations. Right. Here, the marks come in this way. For these 5 marks, these 5 marks and these 5 marks. For the whole diagram, with all the accelerations and forces marked, 20 marks. Now, first equation we write, at time t, the length of the string. At time t, for the length of the string. For the length of the string. What is the length? Here, z plus x plus y. Z plus x plus y equals L. What is L? Length of the string. Right. We can write differentiating twice. Differentiate twice with respect to time t. What do you get there? X double dot plus y double dot plus z double dot is 0, 0. This is number 1. Right. Here, for this 5 marks, after differentiating and taking this 10 marks coming now. Right. Now we apply F equals MA. Number 1, we apply for this P. For this P, right. For P, this direction, make an angle alpha here. Okay. What is the force here? 4 mg sine alpha minus T2. 4 mg sine alpha minus T2 equals 4m. Acceleration of that along this direction, y double dot plus x double dot cos alpha. Y double dot plus x double dot cos alpha. Right? This is number 2. Then next one we apply, secondly, we apply this wedge and the particle P, this direction. Wedge and particle P together, we take as one object. So then, wedge particle, both together when we consider, this T2 act on the particle, this T2 act on this pulley which is on the wedge. This and this will cancel. Right? Equal of it now. This T2 acts on the wedge, but that T2 is the only external force acting for the system, this wedge and this particle horizontally. So therefore, minus T2 come in there. Okay, minus T2 is the external force. Now, on the right hand side, we must write sum of the products of mass and acceleration. First one, mass of wedge 5m, its acceleration is x double dot, and 4m. Okay, acceleration of p related to earth horizontal rightward, x double dot plus y double dot cos alpha, x double dot plus y double dot cos alpha. Then here, this is right number 3. Yes, for the first equation 10 marks, this one 10 marks, for this also 10 marks. Another 3 more equations we must draw. Okay, 3 more equations we must draw. Yes, now we apply for this Q. For this Q we apply. Okay, for this Q we apply. What are the forces acting Q? It's a 2mg downward, T1, T1, 2T1 downward, upwards T2. Okay, upwards T2. Right. Next one, number 3, for Q downward. Downward direction, the forces 2mg plus T1, T1, 2T1 minus T2. Correct, no? On this Q, the forces acting now 2mg downward, T1, T1, 2T1 downward, minus T2 forces. Right. Its mass is what? Mass is 2m. Acceleration is a double dot. This is number 4. For that also 10 marks. Okay, 4 equations we have. Another 2 more we need. The rest 2 you can take how? Applying for this RNS F equals MA. RNS F equals MA. Right? Okay. For R, we can now write for capital R, we can apply upwards. For the upward force, T1, downward mg, T1 minus mg. T1 minus mg is equal to m times acceleration of R upwards F minus Z double dot. F minus Z double dot. Number 5. Fifth one, right? For this S downward, what do you get there? 3mg minus T1. 3mg minus T1 is equal to 3m. S has the acceleration here, F plus Z double dot. F plus Z double dot. Okay. This is the 6th one. Right. For this, you get 10 marks. For this, you get 10 marks. Okay. So this is the first question. Right. Here's the first question. So then number of equations we determine by counting number of unknowns. Right. There are how many unknowns? T1, T2, x double dot, y double dot, z double dot, 5, F6. 6 unknowns are there. 6 equations we must write. Sufficient equations means that. Okay, fine. We'll go to number 2, second question. Yes, who did this question number 2? Who did? Amra did number 2. Yes. Yes, rough thing on something. Fine. Rough one, no? Yes, we'll draw the diagram there. Let me see. We have given. This radius is A. This angle is 60. Okay. This point is D, C. This is B. Right. And given here, a particle P of mass M projected with initial velocity U. Okay. Right. Now asking, show that the radius through which the particle makes an angle theta with the upward vertical. Right. Then theta dot square. Theta dot means angular velocity. No? Right. So in this case, this way. Right. We mark the particle here. Right. Then I'll take it like this. Then you might get guilt there. What surface of this tube the particle contact at this moment? I have drawn that outer surface. The particle is in contact. What if we draw it is in contact with the inner surface? Still correct. Still correct. Okay. Right. I take it like this. The normal reaction Rx so as to pass through the center. Weight mg is here. This angle is theta at time t equals t. At time t equals t, if the particle turns to an angle theta, the angular velocity is given by theta dot. Here, point A. Okay. Right. This BC part, okay. Right. BC part is, people, BC part is rough. BC part is rough. From here to here, BC part is rough. Right. So I'll take the potential energy zero level as this level. This level as the potential energy zero level. Right. You know, this is smooth. Okay. This is smooth. This semicircular tube is smooth. This also smooth. Okay. But this is rough. Right. If this also smooth, okay. When the particle is projected from here, this is smooth now, this is smooth now, this is smooth now. At that moment, the total energy of the particle P, with this all system smooth, the same total energy the particle will have here. Okay. Why? No loss of energy. But you know, when this BC is rough one, once the particle reaches here at the point B, the particle will have same energy as it has here. Then this here energy at A and at B energy being equal. Okay, right. Now, once the particle moves from B to C, since BC portion is rough, the particle will spend a certain energy to move from B to C. Okay. In other words, suppose the person here starts, he had money 1,000 rupees. When it comes here, still the same 1,000 rupees available. But once it moves from here to here, it must pay something to use this BC. Suppose from B to C, it had to pay 200 rupees. Then once the part reaches here, it has 800. right? The same 800 he has here because no what spend in money to move this way. So therefore, we can clearly see there here the loss of energy to move from B to C, right? Loss of energy, right? And the energy here, right? The loss of energy in moving from B to C. And once it reaches the point C, the energy it has. That means for this BC motion, particle spent 200 rupees. Once it come to here, it had 1,000 rupees. It spent 200. Now particle has, when it comes to point is 800 rupees. So therefore, here the amount of money the particle has 800. The amount it spent in moving from B to C, the total is equal to what? Here, total, what amount of money it had. So therefore, how to do this? We can now write. You can see the same energy. If I take is E1 here, it has here E1. Right. If I take the lost energy from B to C, E2, right? And if I take, once it comes here, E3, right? The same energy E3, it will have here. It will have here. All right. So then, what is your equation? The spent energy moving from B to C plus when it reaches to the point C, the energy E3. That means E2 plus E3 should be equal to E1. Understand? But E1 energy is equal to energy here. Okay? E3 energy is here, energy. Understand? Then we can write the loss. Okay? Right. All right. Correct, no? If I take the whole energy as E1, here also it has E1. It takes spends certain energy in moving from B to C. I took it as E2, and it comes to here. I suppose its energy is E3. The same energy E3 it has when it comes here because during this motion, no loss of energy. Then we can apply what? Total energy, what? There, the energy equals what? The loss of energy here and the energy here. Okay? Right. Write down applying conservation of mechanical energy. How to write people there? They are half mu squared, kinetic energy, and mg, h means 4a. That's the total energy E1. Right. Should be equal to what? Here the loss plus the energy here. Understand? Right? No, first one is asking what people? First one is asking, yes. Show that the radius through which particle? Right. Yes, that one. Right. So we have to go to this later. First one is to get the theta dot square down. So no? Yes. We'll count that. Yes. Now we can apply the energy here and energy here should be equal, right? Here, angular velocity is theta dot. Then what is the tangential velocity? Yes, V equals R omega, no? This omega only theta dot. R is the radius. Radius is 2a. Then what is the velocity here? 2a theta dot R omega, right? 2a theta dot. Now we can apply conservation of mechanical energy here for the first one. When I apply that, half mu squared plus 4 mga. Here, kinetic energy and potential energy should be equal to here the kinetic and potential. The other, right, kinetic energy is half m velocity 2a theta dot, no, 2a theta dot perfect square. And at this level, the total potential energy, yes, it is mgh H means this side 2a, this is 2a, no? Then this is 2a cos theta. 2a cos theta. MGH. MGH. H means 2a plus 2a cos theta. Okay, M you can cancel down. Right. Then we can take the answer, multiply this by 2. Then you can take this answer, theta dot squared can be subjected. Right. Simplify this, you get this answer, theta dot squared. It is u squared 1 over 4a squared, u squared plus 4ga 1 minus cos theta. Correct, no? So you can simplify this. Within another one step, you can take this one. Right. Here, marks given this way. Yes. For this 5 marks, for this 5 marks, for this 5 marks, for this 5 marks, and in the middle, simplifying this and taking this last answer, another all 10 marks given. 10 marks given there, right? Okay. Now, what's next one asking? Also find the reaction on the particle by the tube. Reaction R. We apply F equals ma towards the center. Apply F equals ma towards the center. Applying F equals ma towards center. What's that? If this is theta, this angle also theta. R plus mg cos theta is the centripetal force. Right? If mass is m, acceleration is what people, acceleration means what? V squared over radius. V squared over radius means, what is V? 2a theta dot is the velocity. Velocity squared over radius. Radius is 2a. Okay. Then we'll subject R by this. Then there we get here 2 squared is 4. 4 divided by 2 is 2. A theta dot squared minus g cos theta times m. I took m out. Right. Then here we get 5 marks to left hand side, and here 5 marks to right hand side. Okay. Then we substitute for this theta dot squared. Right. Substitute for this theta dot squared. I write m at the beginning. 2a theta dot squared answer this 1 over 4a squared within bracket u squared plus 4ga 1 minus cos theta. 1 minus cos theta, right? Substitute for this minus g cos theta. Right. So for this 5 marks, right? Here you can cancel down this a and with this a squared, 2 and this 4, like this, right? And we can furthermore simplify this. I'm not going to explain about the simplification more. I take the simplified answer coming for R, m over 2a within bracket u squared plus ga times 4 minus 6 cos theta. Right. For this, you get 10 marks. Okay. Now what is asking? Now let u equal root GA. Find the velocity of the particle at BR. When the particle reaches to the point B, it has turned this angle theta. The theta will be equal to 180, no? Here, particle comes this way, and when it comes to the point B like this theta will be 180. Theta will be 180. Correct, no? Right. Yes, now you can write at B, theta equals 180. And we are given U given as root GA. Root GA. This is given. Okay. Now, asking to find the velocity. Right. That can be found, people, here. Velocity is what? 2a theta dot, no? 2a theta dot. Here, we can bring this part this side. Okay. Then we get 2a theta dot perfect square. 2a theta dot perfect square. It is a velocity square, no? Right. Substitute for this u, that root GA, theta 180. Theta 180. Then we get u square means GA, root will eliminate, no? Plus 4GA 1 minus theta 180 cos 180. Cos 180. Cos 180 is minus 1. Okay. Then we get 2a theta dot means velocity. If I take it as v square is here. Then here we get what? 1 minus 1 is here 2, 8, 9. 9 GA root. Then this is nothing but v equals 3 root GA. And this is the velocity when the particle reaches to the point B. Okay. Here, for this step, 5 marks come in, and for this answer, 10 marks come in. Right now. Okay. Now we can write loss of energy. Okay. Yes. Okay. People, now we are given this way. If the particle P just reach to the point D, if the particle P just reached to the point D, what do you mean by just reached? Just reached means once the particle P comes to the point D, its velocity is 0. Velocity is 0. Just reached means that when the particle reaches to the point D, its velocity is 0. That means at the point D, it has no, when the point D, it has no kinetic energy. Okay, right. Now you can see this wave. Okay. The loss of energy BC, we can think like this, no? Here energy E1, that E1 is here energy E1. Right. For this loss of energy, I took as E2. Right. Then once it comes here, suppose energy is E3. The same energy E3, it has where? Here. Because for this motion, no loss of energy. Then you can say what? E2 plus E3 is equal to E1. Understand? Okay. E2 plus E3. E2 plus E3 is equal to E1. Then E2, you can write E1 minus E3. Right. E1 means what? The energy here. That energy is equal to energy here. Therefore, that two energies we can write now E2. loss of energy. E1, it is half m u squared. U given us Ga, no? Ga root half mu squared plus mg h is 4a, right? Minus E3. E3 means the energy of the particle here. That energy it has here. But at this moment, since it has no velocity, it has only the potential energy. What is potential energy? This height you have to measure. This is A. This is A. This is 60. No, A cos 60. A by 2. Then height is 3A by 2. Okay. Then we get mgh 3A by 2. Okay. Then when you simplify this, you get this answer. Okay, no? Right. For mg 1/2 minus 1/2 means 3. Correct, no? 3 mg. 3 mg A. Right, no? Okay, then you get marks like this. Here, 5 marks coming for this. And for this, here's another 5 marks coming. And this one, you get another 10 marks. Okay. Right. So then what is the energy at C? Energy at C. Energy at C is what? Energy at C is asking to find what? Hence, show that the velocity of the particle at C is this much. Velocity of the particle at C. Velocity of the particle asking. Velocity of the particle. How to do that now? Yeah. We can now write energy at C. Energy at C. Energy at C, I took as what, people? E3, no? Right. E3. E3, right? Energy at C, E3. E3 equals, in this equation here, take this E2 right hand side, E1 minus E2. E1 minus E2. What is this E2? E2, this one, right? You know, when the particle is at C, energy E3, it has no potential energy because it is potential energy 0 level, no potential energy. It has only kinetic energy. Am I correct? Yes. Then here I can write half m w squared. W is the velocity of the particle when it passes C, right? E1, E1, we know it is that this energy, this, what is that? 9 by 2 mga, no? 9 by 2 mga, right? Okay, minus E2, 3 mga. 3 mga, right? Here we get 5 marks. And now simplify this, you get the answer of W. W comes as root 3Ga. Therefore, velocity at C, velocity at C, velocity at C is what? 3Ga root For this file, you get another 5 marks. Okay. Next one, the vector question. Vector question. Right. Who did this vector question? Good done. Right. In the triangle ABC, a median is AM using the vector dot product to get this answer. Right? Vector dot product. Yes. I'll use this, huh? This way we have the triangle. Okay. See here, be here, see here. Median means the line joining the midpoint of the side and the opposite vertex. This is same, right? Prove that 2am squared plus 2bm squared equals ab squared plus ac squared, right? Okay. Right. I'll take this angle to be theta. This is theta, right? Theta. This is AB vector. This is since this AM is a median, M is the midpoint. Therefore, this length and this length should be equal. Then first I can write AB vector. I can write AM plus MB. AM vector plus MB vector. Correct, no? By triangle law. Now I take AB vector dot AB vector. We take dot product. AB vector is this, no? AM vector plus MB vector dot AM vector plus MB vector, like this. We can write. This diagram given 5 marks. This step, not this one, right? Next one. Here, when we take a vector dot product with itself, you know what is A dot A? Mod A squared. Then like that, what is AB dot AB? AB vector modulus perfect square, no? AB vector modulus perfect square. This one. But what is AB vector modulus? AB length. AB length. This is AB length perfect square. AB vector modulus means what? AB length. This is AB length. Okay. It's perfect square. So then what is this? AB square. AB square. Right. Now use the distribute law. AM vector dot AM vector. AM vector dot AM vector. What do you get? AM perfect square. Am I correct? AM perfect square. Correct, no? This and this. What do you get? AM dot AM, no? AM perfect square. Next one, this and this. What? MB perfect square. Hmm? Correct, no? Yes. Ah. Now, we have to take this. This and this, we have to take dot product. And this and this, we have to take dot product. What do you get there? MB dot AM and AM dot MB. Hmm? Then it is 2 times what? 2 times AM dot MB. For this, you get 5 marks. Is it clear? Here, AM dot MB. Right? Here also AM dot MB. The order A dot B, B dot A equal. Now, we can write AB squared. We can write AB squared. Right? AM squared plus MB squared plus 2 times. All right. How to define the dot product? AM vector modulus, MB vector modulus, AM, MB. What is the angle between them? What is the angle between them? AM vector is this. Okay. MB vector is this. What is the angle between them? Not theta. Not theta. We know when we define the dot product, the 2 vectors we must draw so as to move, so as to go away from a point like this. So this is the angle theta. Then this is 180 minus theta. 180 minus theta is the required angle. Cos 180 minus theta. Okay. AM modulus means AM length. MB modulus means MB length. Okay. Then I can write AB squared is equal to AM squared plus MB squared 2 times AM length into MB length. Cos 180 minus theta is minus cos theta. Then this is minus. For this step, you get 5 marks. Okay. This is equation number 1. For this also, you get 5 marks. Right. Next one. AC vector I can write. AC vector. AC vector I can write AM plus MC. AM plus MC. AM plus MC. Now I take AC vector dot AC vector. And then right hand side AM plus MC dot AM vector plus MC vector like this. Left hand side AC dot AC means AC squared. Here we get what? This and this when you take dot product. AM vector dot AM vector means AM squared. MC vector dot MC means MC squared. And as before here, we get 2 times AM dot MC. AM vector dot MC vector, right? For this, we get 5 marks. 5 marks we get. Okay, now I can write furthermore this way. AC squared equals AM squared plus MC squared plus 2 times AM vector dot MC vector, outright AM modulus, MC modulus. AM vector modulus means what? AM vector modulus into MC vector modulus cos. What is the angle? AM vector means this. This MC means this. This is the angle we need. That angle going to be this theta, no? This is theta, cos theta now. Okay. The angle between two vectors mean what? We must draw the two vectors starting from a point so that both the arrows going out from the point. Then the angle between the vectors is the angle theta. Yes. For this, the 5 marks. Yes. Then I can write AC squared. How? AM squared plus MC squared 2 AM MC cos theta, right? This is number 2. Right here, 5 marks. Right now, add 1 and 2. Add 1 and 2. Add 1 and 2. One plus 2. When you add 1 and 2, left hand side of 1 we have AB squared. Left hand side 2 we have AC squared. At the right hand side, AM squared, MB squared, right? Minus 2 AM into MB cos theta. To this, we have to add what? Right hand side of number 2 is AM squared plus MC squared plus 2 times AM MC cos theta, right? Yeah, you know, here is MB and this MC equal because M is the midpoint, no? MB MC equal means here this MB and this MC equal. Then what happens? These two terms will cancel. Here minus, this is plus, cos theta, these two equal, no? These two will cancel. Then what do you get? AM squared, 2 AM squared. And MB and MC equal, no? Here, MB and MC equal, no? This also I can write as MB. This also MB, no? Right. Then we can write AB squared plus AC squared is equal to this and this 2 AM squared. MB and MC equal. MB and MC equal. For this also we can put MB. MB squared means MB squared plus MB squared is 2 MB squared. Take 2 out, we get like this. Right. Then you get another 5 marks for this. Totally 40 marks come in for this, up to here. For the diagram, 5 marks. 40 marks come for that. Next one. The position vector of 2 points P and Q related to a vector origin O are simple P and simple Q respectively. Find the position vector of the point R which divides the line PQ in the ratio lambda is to mu internally. Lambda is to mu internally, right? From that. That means ratio theorem, ne? Ask into prove ratio theorem. ratio theorem asking who there. Right. This way, we'll do the diagram there. QO. This point is Q. This point is P. The position vectors Q here, P. This is simple P. This is simple Q. Right. Point R is here. OR. Right. The ratio is lambda is to mu. The diagram given 5 marks. Okay. OR vector you can write this way. OR vector OP plus PR. OP is simple P. PR vector, P to R vector you can write as a part of PQ. PQ vector should be divided by what? Lambda plus mu sum. Then to take this PR part, this should be multiplied by mu. Okay. Then for this PQ vector, you can write PQ vector means what? PO plus OQ. That means what? Q minus P. Put that Q minus P here. So R vector is equal to P plus mu over lambda plus mu. PQ means Q minus P. Right. What is 5 marks? It's 5 marks. For this 5 marks. And simplify this. Once you simplify this, you get this asking vector. Take lambda plus mu as the common denominator. By that, you have to multiply this and simplify with this. We get that lambda P plus mu times Q. Right. For this 5 marks. Right. This ratio theorem we have proved. Therefore, in the next part of the question, we can directly use this result. We can directly use this result since we have proved it. Yes, read the next part. Okay. Next part. The position vectors of the points A and B, root 2 and origin O, simple A vector, simple B vector respectively. The point P is such that OP equals for OB, right? Okay. I will do the diagram there. This way we have OA, O here, A here. Right. Position vector of A is simple A. This vector is A. I read that here too. Right. Obvious here. Okay. Here B. Here B. The point P is such that OP equals for OB. All right, that's also correct. The midpoint of AB is Q. Midpoint of AB is Q. Right. We'll do the midpoint. Midpoint of AB is Q. Here Q. These two are equal. Midpoint of AB is Q. That's next. And the point R is such that OQ QR 5 is to 3. OQ QR 5 is to 3. Here Q. OQ QR 5 is to 3. OQ is 5 units. QR is 3 units. OQ QR 5 to 3, right? Give it. And next one given us this OP vector for OB. OP vector is for OB, right? And right. Let us consider the point S so that OS equals mu OQ. Right. If PS is parallel to BA, find the value of mu. Hence show that R lies on the line AP, right? Let us consider point S so that OS mu OQ. Mu OQ. Right. People, you are given something like this. Mu here OS vector mu OQ. What do you mean by this? OS equals mu OQ means what? OS Q should be on the same line. Okay, that means on the line OQ produced a slice. This is it. And now, if PSC is parallel to BA, given no, PSC is parallel to BA. This side and this side parallel. Yes. Two are parallel. Okay. Right. Ask me to find some answers. Right. Ratio theorem we can directly use. This ratio is 1:1. 1:1. Q is the midpoint. No. Right. Asking. Right. Asking OQ. All right. This way, no. For the diagram, 5 marks come in. No. For the diagram, 5 marks. Right. OP, we can write. OP is equal to 4 times OB, no? OB. OB, the position vector of B is B given, no? This is B. Right. Then OP is 4B. 4 simple B vector. OQ vector. OQ vector. Q is the midpoint. Apply ratio theorem. 1 is to B plus 1 is to A divided by 1 plus 1. We can directly use ratio theorem because in the first part we have root, right? OQ, A plus B by 2. B by 2. For this, you are given 5 marks. For this, 5 marks. What are the vectors asking? OR, next one asking. OR. Right. OR. OR vector, you can write. Hmm? Yes. People tell me how to write OR vector. Yes. From here to here, the vector we need. Okay. Right. First, we take OQ. From OQ, 5 parts available. Then divide in OQ vector by 5, we get 1 part. Understand? From O to R, how many such parts available? 5 plus 3, 8 parts available. Then tell me how to write OR vector. OQ vector, we divide by 5. Then we get 1 part. To get OR, we need another 8 parts like that. Okay. So therefore, OR vector you can write first OQ vector we divide by 5 and take 1 unit. And to get OR, we need 8 units. Multiply this by 8. For these 5 marks, then we get OR. 8 divided by 5, OQ vector A plus B by 2. Okay. We get what? OR vector. Yes, simplify this. We get 4 divided by 5, A plus B. For these 5 marks. Next one, asking AR vector. AR vector you can write this vector. AR vector you can write AO plus OR by triangle law of vector addition. AR vector you can write AO plus OR. AO vector, AO vector, O to A vector is A to O minus A. Minus A. OR vector just now here found. 405 A plus B. Then for this 5 marks. Okay. Then simplify this. We get AR vector. AR vector is coming 4B minus A divided by 5. For this 5 marks. Okay. AR vector also correct. And asking RP vector. RP vector is RP vector. Right. Now I can write RP vector like this. RP vector you can write RO plus OP. RO plus OP. RO vector plus OP vector. RP vector. RO means minus OR. Right. OP, 4B. Put them there. Minus OR means minus 4 by 5. A plus B. OP vector is 4B. 4B. Here we get 5 marks. Then simplify this for RP. RP we get taking common denominator as 5. When you simplify this, we get 16B minus 4A. Right. For this another 5 marks RP. Really, you can take yes 4 out from this, no? When you take 4 out, we get 4 here. 4B minus A. 4 minus A divided by 5, yes. For that 5 marks. Then we can write here RP vector 4 upon 5. I can write this 4 times. Here. When we take this one, 4B minus A divided by 5. Look at this. I wrote the same RP vector which is here available. 4b minus a divided by 5. 4b minus a divided by 5 is nothing but AR. Put here AR. RP vector is equal to 4 times AR. Okay. Right. For this, we get 5 marks. Okay. Now, what can you say? RP, AR, parallel. No. No. RP vector equal to 4 times AR vector. When two vectors are equal means what? Corresponding line segments are parallel. Okay. RP and AR should be parallel. What can you say? RP and AR parallel means this ARP should be on the same line. ARP should be on the same line. This gives us what, people? RP parallel to AR parallel to RP, no? AR parallel to ARP. AR parallel to RP. AR parallel to RP. Hence ARP. Hence ARP are collinear. ARP are collinear, no? Are collinear. Lie on the same line. R lies on AP. Okay. For this one, the 5 marks. R lies on AP, correct, no? ARP collinear means these 3 points ARP lie on the same line. It means what? R lies on the line AP. R lies on the line AP. Huh? That's the meaning. All right. Now ask the next one and find the ratio AR is to RP. AR is to RP. All right. AR is to RP. AR is to RP. Here we have what? RP vector going to AR, no? When two vectors are equal, left and right, the sizes also equal. All right. Then we can take here. What is this ratio? All right. RP, bring this AR here, divide by AR equals 4/1. Now we said what? ARP on the same line, no? Here A, here R, here P. Okay. Now, RP 4 units. Here to here 4 units. AR 1 unit. 1. Then what is the asking answer? AR RP. Therefore, AR RP ratio is 1:4. This gives AR is to RP equals 1:4. Okay, for that we get another 5 marks. Another 5 marks coming now. Right. The last part. Okay. OS equals mu OQ given. Right. If PS is parallel to BA, find the value of mu. Right. OS equals mu OQ. At PS. PS parallel to BA. PS. All right. Okay. I will come that. Okay. We can first write PS. PS vector we can write PO plus OS. PO plus OS. PS vector we can write that is PO OP OB no PO minus OB OS. People, you can write OS here. OS, right? We are given OS is equal to mu OQ. This is given. OS mu OQ. Then for this OS, I can put mu times OQ. OQ. OQ we found earlier, no? B. OQ. Yes. OQ. A plus B by 2. A plus B by 2. Okay. Right. For this, we get 5 marks. We get 5 marks for this. Okay. Now we are given PS, since PS vector, PS parallel to BA, PS and BA parallel. Then we can write PS vector, I can write lambda times BA vector. PS vector parallel lambda times BA vector. PS vector lambda BA, because PS parallel BA given. But lambda is a real number. Lambda is a real number. Substitute for PS minus OB plus mu times A plus B by 2. Lambda times BA vector means A minus B. Right? Right. For this, we get 5 marks. Okay. And now this A and B are what? A and B are what? 2 non-zero, non-parallel vectors. Two non-zero, non-parallel vectors. So therefore, we can equate the coefficients of A and B left and right and find mu. Equate the coefficients of A in the left and right. Mu by 2. Right hand side, lambda. Equate the coefficients of B in the left and right. B here, minus 4. Here, mu by 2. Plus mu by 2, right hand side, minus lambda. Right. For this, you get 5 marks. For this, you get another 5 marks. Okay. Now here, for this lambda, we put that mu by 2. Yes, then we get the arms of mu as 4. Substitute here for lambda. Minus 4 plus mu by 2 is equal to minus. Lambda means mu by 2. Bring this here. So mu comes as 4. For that, we get another 5 marks. For this question, total is 150 marks. It contains more work to do. 150 marks. Yes. Not out of 100, you get there, right? Okay. Question number 4. Covalent forces question, no? Yes. Question of forces ABCD is a parallelogram such that AB equals BD, L of root 2, and AD equals L. ABCD is a parallelogram. ABBD L of root 2. AD is L. Right. Even now, AB BD L of root 2. If I take like this, suppose parallelogram. AB CD no. This and this being equal L of root 2. This is given as L AD. Right? You can see square of this is equal to square of this. Hmm? This square means L squared over 2. This square means L squared over 2. Their sum is L squared equal to this. Then this ABP should be what? Right angle triangle. Right angle triangle. So must very carefully understand that. Huh? Right angle triangle. Right. Okay. Here is this all. Right. AB horizontal, ABCD order is in anticlockwise sense. The line drawn from C parallel to BD intersect AD produce at E. All right. This is A, B, C, D. Right. Okay. This AB produce this. AE. Right. A 9 to the upper. This length is L over root 2. This length and this length being equal. This is L. Right. This also the same. Opposite sides are equal, no? Here 90. Okay. Right. So then this is 45, yeah? This is 45. This is also 45, yeah? The same AD produced here we have, same AD produced here we have. AD produced like this we have. AD produced like this. This is the. Then this also 45. Therefore, this 45. Then this side also same. Right. L over root 2. This length L over root 2. This also L over root 2. The red are lengths. Don't confuse that. Okay. Now forces acting like this, no? What are the forces acting? This way, maybe this way, in the order of letters, the forces are acting. Yes. Here too. Here too. Here 6 root 2. This way Q. This is P. This is 4 root 2. Here, this is 1. Okay. Yes, for the diagram, 10 marks coming, no? 10 marks coming. Right. What is the first question asking? If the system of forces reduces to a single force acting along BD, find the forces P and Q. Also find the magnitude of the single force. Right. The system of forces, people, given system of forces reduces to single force acting alone what BD, acting alone BD. Right. A force acts alone this way. That means this whole system will give resultant force. That resultant force acts along the line BD. Okay. Then you know, when you take moment around D, resultant is passed to the point this, no? Right? We have learned one theorem this way. If we have a system of forces like this, right? And if the resultant of them is R, okay, around any point on the plane, suppose so, first we can find the algebraic sum of the moments of these forces. That algebraic sum of the moments of these forces around any point is equal to what? Around the same point, moment of R. Right? Okay, that we said. Now, here also the same result we can apply. Resultant force acts alone BD. Since resultant acts alone BD, when you take moment around D, moment of the resultant is what? 0, no? Resultant force passing through BD. When you take moment around D, since resultant passing through point D, R doesn't give any moment. That means what? This is 0. Should be equal to what? This. What do you mean by that? Around D, the algebraic sum of the moments of the forces should be 0. Understand? Why? the resultant passes through BD. Not only D, since the resultant passes through point B, again, around B, the algebraic sum of the moments of the forces should be 0, according to this theory. Then we take moments around B and D to find P and Q. I don't like this. Since the resultant force passes through, the points B and D, the algebraic sum of the moments, of the forces, around B and D should be 0. Right. First we take around B. Around B should be 0. Around B, what do you get? These three forces, these three forces won't give. Around B, we'll take this way. Yeah. This Q gives what? Around B. Q gives around B anti-clockwise moment. This one gives clockwise moment. 6 root 2, 4 root 2. 6 root 2, 4 root 2. Same line, no? We can take 10 root 2. Okay. Around B gives but clockwise. Then how many forces? 6 root 2, 4 root 2. Around B gives clockwise. 1 also clockwise. Q anti-clockwise. Okay. Then Q into, right? Q into the purple distance to this Q from B. This is 90, no? L over root 2. Q times L over root 2. Right. Minus others. This one goes this way. The length is this L over root 2. 1 into L over root 2. Minus 1 into L over root 2. Right? Okay. Now, people, here, this 6 root 2 line n, 4 root 2 line same. 6 root 2, 4 root 2. We can take 10 root 2. 10 root 2. That 10 root 2, now we can assume acts here. 10 root 2. Resolve this 10 root 2 into 2 components. 10 root 2 cos 45. It passes through the point B, no moment. 10 root 2 sin 45. This way gives around B clockwise moment. Perpendicular distance is L root 2, L over root 2. Then we get next minus sign coming. Sum of the forces 10 root 2. Right. 10 root 2. We resolve that force horizontally and vertically. Horizontal component passes through B, no moment. Vertical component 10 root 2 sin 45. Sin 45 means 1 over root 2. That force acts here this way. To that, the perpendicular distance is L over root 2. L over root 2 should be equal to 0. Then, people, this L over root 2 we can cancel down everywhere, right? Then we get Q here minus 1, here 10 equals 0. We get Q as 11 newtons, right? The marks come in here. Yes. 5 here, 5 here, 5 here. Simplifying and taking this 5. Okay. Also, we take moment around D. Okay. We take moment around D. Around D should be, the moment should be 0, no? Right. Around D. All right. Take moment around D. Right. When you take moment around D, This Q does not give any moment. This 2 doesn't give. This 6 root 2, this 4 root 2 do not give any moment. Then we get this 1 clockwise P, clockwise 2, and clockwise. Right. We'll take around the clockwise moment. Right. What do you get? 1 into L over root 2, clockwise moment. 1 into L over root 2. Right. Okay. Here 45 no? Huh? Resolve P at this point. P cos 45 passes through D no moment. P sin 45 acts this way. To that, the perpendicular distance is L over root 2. P sin 45. Sin 45 is 1 over root 2. Then we get P into 1 over root 2. Is that false? Right? This is 45 now. Resolve this P at C. This way, it passes through D no moment. Other one is this way. P over root 2. The length is L over root 2. L over root 2. Then around D, we get clockwise moment. Right? Then anti-clockwise moment come in only by this 2. 2 into L over root 2, that is minus. This should be equal to 0. Again, this L over root 2 we can cancel down. Then we get the P answer as root 2. Right. Here, marks come in. Yes. Left hand side, this part 5. This is 5. This is 5. This way we get that. Huh? Okay, now also find the magnitude of the single force. Then we can resolve. We can resolve. Because we know the resultant force is vertical now. We'll resolve this way. Horizontal component should be what? Resultant is acting vertically. Then it has no horizontal component. X is 0. No? I take the result, the force. Right. What is the force? If I take it as y, that is the size. Resolve upwards. What do you get? 4 root 2, 6 root 2, 10 root 2, cos 45. Upwards. 10 root 2, cos 45. 1 over root 2 is the cos 45 answer. Here 2, upwards. Here 1, downwards, minus. Here P, what is P? P sin 45, minus. Root 2 into sin 45, root 2. Then we get 10, no? Comes as 10. Upwards direction 10, it is 10 newtons. Okay. So, here 5 marks coming. Right. So then you have to write. Therefore, magnitude of the single force is 10 Newton force, upwards direction. In sentence wise, you must write. Right now, therefore, magnitude of single force is 10 Newton. This way, BD direction, BD direction. Okay. Next question asks you this way. Second one. Find the force which must be added to the system above at B for the system to be in equilibrium. Tell me what force we must add to bring the system in equilibrium. Yes. There is certain upward 10 no, that acts B to D. Then to bring equilibrium, downward force needed 10. At the point B, downward force 10 must be applied. Write down that. The force 10 Newton should be applied at B. The force 10 Newtons should be applied at B. The force 10 Newton should be applied at B in the direction dB. in the direction dB. Okay. So that 5 marks come in, na? 5 marks. Okay, go next part. Yes, now it is given this way. You must draw another new diagram. Here we are given this way. The direction of P and Q are reversed without change in their magnitudes. P is root 2, no? The direction other way. Root 2 this way. Q 11. This is direction is other way, 11 this way. Okay. The second diagram is this, Okay. What is asking now? Find the magnitude and line of action of the new resultant force. All right. Magnitude and line of action, right? Now, no longer the resultant force acts how? BD. Okay. Right. Resolve horizontally, resolve vertically. Resolving horizontally, take X. What do you get there? 2 plus 11 plus 10 root 2 cos 45. No, here. 2 plus 11 plus 4 root 2, 6 root 2, 10 root 2 cos 45. 11 plus 2, 10 root 2 cos 45. 1 over root 2. Here. 13, 10. Other one is there. 11. Right. Here root 2, no? Root 2 cos 45. That also coming, no? Plus root 2 cos 45. Cos 45 is 1 over root 2. Then here 1, here 10, 11, 11, 13, 40, 24. No? This way we get 24 newtons. Resolve vertically. Why? We get what? 6 root 2, 4 root 2, 10 root 2, sine 45. It's 10. 10. Here 2 we have this 2. This 1 minus. And this root 2 cos 45 upwards. Root 2 cos 45 means 1. Then we get 12 there. Right. For this, we get 5 marks. For this, we get another 5 marks. Then what is the resultant force? If I take the result to be R, here X we have 24, Y we have 12. Let this angle be alpha. Then what is R squared? R squared we can write. R squared is X squared plus Y squared root, no? R squared, X squared plus Y squared. 24 squared, 12 squared. This 24 I can write 12 into 2, no? Perfect squared plus 12 squared. Take this 12 squared out. Then here 2 squared is 4. Once I take this out, we get 5. In R, we get 12 root 5 newtons. And remember, whenever you find the force, not only the size, but direction also you must find. Then tan alpha you can write. Tan alpha. Tan alpha is y over x, no? 12 over 24. Alpha, tan inverse half. Tan inverse half. Okay. Then here the size, 5, direction also 5 marks coming, no? Okay. Now, magnitude and the line of action of the new resultant force. Line of action mean we must find, right? We must find the point where the line of action resultant cuts in the diagram, right? Okay. Okay, right. Now I draw that line of action of resultant this way. Then you can write its horizontal one and vertical one. Vertical one is 12, horizontal one is 24. We need only the 12. This 12 only we need. All right. We take moment around B. Right. You know, algebraic sum of the moments of the forces should be equal to what? Moment of their resultant. Thereby, I supposed to find this length. Suppose this length to be D. D. This D. To find that D, I take moment around B. Take the moment around B. Take clockwise moment. Take clockwise moment around B. When take moment around B, we'll take clockwise moment. This 2 doesn't give, this 2 doesn't give, this root 2 doesn't give, right? 6 root 2, 4 root 2, 10 root 2. Resolve vertical. 10 root 2, sine 45. Sine 45 is 1 over root 2. Now that force acts this way. Around B, moment is clockwise. The distance from B to A is L over root 2. L over root 2. Right. We took the moment of 6 root 2 and 4 root 2. Right. This 11 gives again clockwise moment. To that moment, 11 into L over root 2. Plus that also clockwise. 11 into L over root 2. This also we took. Next one is 1. Around B, 1 gives what? Clockwise. When I produce this way, the length this we need. The force is 1. The distance from here to here, L over root 2. 1 into L over root 2. Right? Then we took the moment of this 1 we took, 4 root 2 and 6 root 2 we took. By 11 we took, right? That's all. Now that should be equal to what? Moment of the resultant. The resultant I resolve horizontally and vertically. Horizontal part passes to the point B, no moment. Vertical part 12 gives clockwise 12 into D. 12 into D. Now you have to find this. Right? This and this you can cancel down. Take L over root 2 out. Here 10, here 11, and here 1. 12D. Here we get 22 equals 12D. Here L over root 2. Here 6. Here 11. Then we get D. 11 simple L over 6 root 2. Okay. Yeah, for this moment equation also, 5 marks given. The left hand side, whole thing 5 marks. Right hand side, 5 marks. This is 5 marks. Right. So this must be written in words. Okay. For that one, last 5 marks given. Then you must write how? The line of action of resultant cuts the side AB at a distance 11L over 6 root 2 from B. Okay. Write down that in words. For that only 5 marks finally given. The line of action of resultant cuts the side AB at a distance 11L over 6 root 2 from B. For that, we get the last 5 marks. For that, you get the last 5 marks. Right? Okay. last 5 marks, something like that. Okay, we come to the number 5. Join the dots part. Okay. Yes. Here the question given this way. 5 uniform roads A, B, B, C, C, D, D, E, and E are joined at the ends, right? Form a pentagon like this, huh? Weights given. Smooth joint at that B, E, D, B, E, and D. Yes. The framework is really suspended from A and it is in equilibrium in a vertical plane. Find the horizontal and vertical components of the reaction at the joint C. Write down sufficient equation to find the stresses in the rods. Okay, who did this? Yes. This time the paper, really, I put some questions for the paper. This was the 2023 last final paper, model paper published by the education department. Okay, those questions, good questions. Once you work with these kind of questions, really, you get a good knowledge, right? So we'll draw that too. The weight W, this length is A, this is A. Here also weight W, A and A. The tension I'll take here. Sometimes the really this rod should have a thrust. We know that, but we mark them as tension. What will happen to the final answers? They will be negative. Tension negative means thrust. So therefore, don't worry about exact nature. This is T2. T2 here. T2 here. Here 2W. Here 3W. Right. This length is B. This is B. Here we mark the reaction at the point C. Here B. Here B. Here B. This angle given as beta. 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 This is beta. This is also beta. For the diagram, 5 marks are enough. Here B. Here B. Beta. Yes. Yes, you know, this angle and this angle equal, no? Because this is 2B, this is 2B. Then this angle and this angle equal. Hmm? This is CD and this is B, no? BC, CD equal. Therefore, this angle equal. But their sum should be equal to beta. Hmm? This and this add up to beta. And this are equal. Then each should be beta by 2. This is beta by 2. This is also beta by 2. Right. But this whole angle, what? This whole angle should be equal to this angle beta. Therefore, this is also beta by 2. Now asking what? And the horizontal vertical component of the reaction at the joint C. Okay. Right. For the equilibrium of the DC rod. For the equilibrium of the DC rod, take moment around D. For the equilibrium of DC, take moment around D. Hmm? When you take moment around D, what do you get? You take clockwise. Y into 2B. Y into 2B equals W, 3W into B. Then we get Y 3W by 2. For this 5 marks, for this 5 marks, right? Secondly, for the equilibrium of BC, for this rod, we take moment around B. We take moment around B. We take moment around B clockwise. What are the forces? 2W, B cos beta, no? Y, X anti-clockwise, right? 2W, B cos beta plus Y, 2B cos beta. Correct, no? This is Y, no? This way, this length we need. This is beta, no? 2B cos beta. Should be equal to what? X into this height, 2B sin beta. 2B sin beta. B you can consider out. Okay. X we can simplify by this. Substitute for Y, 3W by 2, no? then we get x, this answer. Phi w pi 2 cot beta. Okay, this moment equation, you get marks like this. For this 5 marks, for this 5 marks, for this 5 marks, final answer 5 marks. Okay. Next one asking what? Next one asking, write down sufficient equations to find the stresses in the light rods. T1 and T2 we need to find. Here A, here T dash, this angle given as 2 theta. Right. Right. Now, for EDC part, we take moment, right? EDC part. EDC part, we take moment around E. For EDC part. For EDC part, we take moment around E. We take moment around E. Clockwise. Right. Around E, we take clockwise. Right. What do you get there? Around E, clockwise moments. Around E, tell me the clockwise moment forces. T2. T2 use what? Clockwise. Y? What? Clockwise. X? Also clockwise. 3W and 2W and clockwise. Right. Okay, take that. Correct, no? When you take this E, D, C, this part we take. There, think that around D, this ED and DC can't rotate. And it can only rotate around E. That is how we think whenever you take the moment for a certain portion. E, D, C part, we take moment around E mean at D, it is rigid. ED and DC can't rotate around D. Then very easily you can think the sense of the moment. Okay. And it can, E, D, C part can only rotate around E. Right. That's occasion. Once we apply T2, this part moves rotate clockwise. Then Y clockwise. X clockwise. 3W and W anti-clockwise. Take moments. Right. T2. T2 we said what? All right. T2 we said. People, T2. Take like this. T2 resolve this way here. T2 cos beta by 2. T2 sine beta by 2 this way. Take the two components and take moment. If not, do we have another way of getting that? Just if I drop a perpendicular here, that perpendicular distance we need now. What is this? (180) minus 3 beta by 2. That into 2b sine, no? Right. Like that, you can take T2 into, right, 2b, this angle, isn't this angle, we need sine. 2b sine 180 minus beta plus beta by 2. 3 beta by 2. 3 beta by 2. That we got. Right. T2, okay. And x also, right? This way. What is the distance to that? This is line of action of x. The perfect distance from E, this. What is that? 2b sine beta. 2b sine beta, right? Y, Y also anti-clockwise moment. Y into what is the length we need? When you bring this way, line Y from here to here, length we need. What is that length? Is 2b, and from when we project this way, perpendicular, 2b cos beta, 2b plus 2b cos beta. Is it clear? Ya 2b plus 2b cos beta, 2b cos beta, right? Equals what? This 2w. What is the line this way? B cos beta, 2w into b cos beta, b cos beta, right? Why this 3w? What? When you put this way, from here to here, b, and when we bring this way, 2b cos beta, 3w into b plus 2b cos beta. All right, this way we get, right? Right. Here, 10 marks, for the rest, 5 marks each given. 30 marks for that one. Next one for ABC part. For ABC part, we take moment around A. Right. Take moment around A. Yes. We'll take moment around A and the clockwise moment. Now think the ways of getting moments. Now how to think? A, B, C part. Now we don't think that A, B, and B, C can rotate around B. It is rigid here. Only around A, B, and B, C can rotate. That occasion, W gives anti, T1 anti, T2 anti. This 2W also anti, no? Anti. Y also anti. X also anti. Okay? Right. Then take the moment. Right. Take W into what? This length. Put it this way. This way. Right. This is theta, no? Symmetric. Therefore, this is 90 minus theta. This is theta. A sine theta. W into A sine theta. W into A sine theta. Right. You will tell me what is this moment of 2W? 2W moment. This length we need. This length we need. What is that? From here to here, what? From here to here, what? 2A. This angle theta means, right? This also theta, no? 2 theta means theta, theta. Right. Then the length from here to here, it is 2A sine theta. But we have to subtract this part. What is that? B cos beta. Correct, no? 2W into 2A sine theta minus B cos beta. B cos beta. Right. This and this both we took. By this Y, tell me, by the Y, what distance when you produce this way? Right? This 3W going through the point A. And then the distance to this Y from this A going to be this distance B, no? Y into B. Y into B, no? So when I produce this way, here, the length is B, Y into B. Y into B. This Y also we consider. Now by this X, X means this length we need, this height we need. What is this height from here to here? 2A cos theta. What is this height? This is beta, no? Then 2B sine beta. x x x into this is 2a cos theta, 2b sin beta, 2b sin beta, 2a cos theta, 2b sin beta. All right. X also we considered. Right. T1. What's that? This height. 2a cos theta plus T1 2a cos theta. Another one more. T2. Right. I'll take T2. T2 resolve this way. What's that? T2 cos beta by 2. T2 sin beta by 2. Resolve and take. Now, T2 cos beta by 2. That component comes along this line. Peripheral height is 2a cos theta. 2a cos theta. Next one, T2 sin beta by 2. That passes this way. T2 sin beta by 2. T2 sin beta by 2. To that, the distance is this from here to here. This length. This is theta now. 2a sin theta. This is equal to 0. For this also, 30 marks. 35 marks come in for that. 5, 5, 5, 35 marks. Right. So this is how we take that answer. Right, the last one. Right. Next one is yes, Gauss notation part. Right, people. Though we do this type of questions, I'm sure that this kind of questions you never get at the AL paper. Then you might ask, why do we do? Now, when we do like this only, you can clearly see the way of taking moments and the practice thoroughly come into your mind. When we, of course, perform like that, at the examination, no chance of going wrong and no chance of failing the question is difficult. Okay? Therefore, don't worry about these questions, right? Must do them, right? කරන්න ඕන ළමයි නැත්තම් මේ ප්‍රැක්ටිස් එකට එන්නේ. Okay, the next one was notation part, last part. Okay. Yes, this you are given. Right. The diagram is this. We have vertical line. Here at A there's a hinge. Okay. Here 2W force acting. Right. These three are equal. Therefore, this is an equilateral triangle. BCD. BCD. Here force P is acting horizontally. Right. It will be in a vertical plane by applying constant force P at C. Yes. Such that AB makes an angle 30 with the downward vertical. This is 30 with downward vertical, right? Downward vertical 30. B at 90. And the magnitude of the horizontal force P. Right. We'll take moment around A. At A, it is hinge, no? Hinge at A. Right. Let us take this length as A. A, A, A. This length also same. Right? This is 90. This length and this length A. Therefore, this is isosceles, no? This is 45. This is also 45. Two sides of this right angle triangle equal means angle should be 45. I assume the length as A equal sides. We'll take moment around A. We'll take moment around A. This is 60, no? This angle is 60. Why? This is equilateral triangle, no? 60, 45, 105. Then this angle is 75. Right. We take moment around A. We take moment around A. Right? We'll take anti-clockwise moment. P gives anti-clockwise moment. No? P multiplied by when I produce this line, this way. Right. Okay. Right. This height we need to take by that. Right. When I construct this way, what is this? A cos 30. When I construct this way, this is 60, no? This is 30. Then what is this? A sin 30. P into A cos 30 plus A sin 30. P into A cos 30 plus A sin 30 equals 2W. Right. When you drop a perpendicular like this, okay, this length only we need. Drop perpendicular like this. This length from here to here, that is equal to this. A sin 30 plus next part this from here to here. That is equal to this, no? 60, A sin 60, A sin 30, A sin 60, A sin 60. Correct, no? When simplify this, you get P equals 2W. For this 5 marks, for this 5 marks, for this 5 marks. Right. That way we get. Find that way the distances, right? P equals now 2W. Right, no? Then this right constructions to find the lengths are used. I am going to erase to get a clear picture here now. this A, and also 5. So it's better to draw new diagram for the next part. Otherwise, your diagram will not be clear enough. Okay. I will close this by close curve. We are not asked to find the reaction at the hinge. So therefore, do we cover including that also? No, not asking, no. Asking only what? Tensions in the string, stresses in the rods, no? Hmm? Yes. That's all, no? Right. Then we can cover it like this. This way will cover it. Why? It is not asking to find the reaction at the hinge, right? So this region is A. This P I take as now 2W because we found that P is 2W now. P is 2W. This is A. This region is B. Now this region is now C. This region is D. This region is E. Right. Right. Now let us draw. Yes, now here AB downward W, DA rightward W. No, all right. AB downward W. AB downward W. This way. AB downward W. AB downward 2W. 2W. No, say this B. This is 2W. Right. DA horizontal 2W. That means D point should be like this. Okay. D here, this is 2W. Right. Now, on this joint, AE vertical, it should be somewhere on this. Right. ED must make 30. D here now. From D, we'll draw line parallel to BC, making 30. Horizontal 30. This way. Okay. I drew this line parallel to this BC. All right. It makes 60 with the vertical, 30 with the horizontal. Then E here. Right. This is 30. Right. That's correct. And now we can go to this joint D. Also, we can go to this too. That's also much easier. Joint B. CD must make 30 with the vertical. CD DC. Here. This AB road, no. That makes 30 with the vertical means 60 with the horizontal. That should be CD. Then to the point D, we must draw a line parallel to AB, meaning making 60. Another 30 we must draw like this. This is 30. Somewhere on this line, we must have what? Somewhere on this line, we must have what? The point C. Right. CE, E we know. CE must make here. CE means this BD road, no? BD road must make 60. Then from the point E, we draw a line parallel to this DB, making 60. And this is 60. Right? This should be the point C. DC and CE. CD means this. CE is this. Between them, 90. This is 90. This is 30. Therefore, this is 60 again. Right. Then join this BC. We get like this. BC here. BC makes with the vertical 75. Then where is the 75 angle? Here. This is 75. Okay, this all. This whole thing is 2W. 2W. Right here. DE cos 30. 2W, no? DE cos 30. 2W. This is 30. This is DE. DE cos 30, 2W. Then we get DE 4W over root 3. 5 marks. Next one, AE. AE. This. What's AE? DE sin 30. DE sin 30. DE we know 4W root 3 sin 30 is half. We get AE 2W over root 3. 2W over root 3. So that also 5 marks. CD next. CD. Here, CD. It is DE cos 30. CD. CD means this, no? DE cos 30. Right? DE we can put here. Cos 30 we can put here. Then we get CD 2W. So that also 5 marks. CE next. CE, it means DE cos 60. CE is equal to DE cos 60. For CE, we get 2W over root 3. We can substitute here, no? 2W over root 3. 5 marks. Huh? Okay. Next one, by this CEB triangle, we can apply sine rule by CEB triangle. CE divided by sine 75. CE divided by sine 75 equals BC divided by sine 60. Sine 60. CE we know. Then BC we can subject. Okay. This gives us BC. What is BC? We get BC W of sine 75. W of sine 75, right? Applying this sine rule 5 marks. for this. Okay. And this way, write in 5 marks. Sine 60, we put root 3 by 2. And CE also we substituted. That is how we get this BC, this answer. And this sine 75, we write this way. Sine 75. 75, we write as 45 plus 30. Okay. Then we expand this by using sine A plus B formula. Sine 45 cos 30 cos 45 sine 30. And put substitute in the values, you get for BC 2 root 2W over root 3 plus 1. Okay. For that you get 5 marks. Right. So then the last part. Okay. Table we have to put here. Here road, force, tension and thrust. Okay. But the forces are acting like this, no? Here, to balance this leftward one, we need this way. This goes up, no? Downward here must have. Right. Okay. Then here. Here 90, no? By this stress, no component in the perpendicular direction. By this force in the rod AB, it doesn't give any force in the direction perpendicular. That means by this AB rod, no force coming along this BD. Right. Then this force, when I consider this one, it has a component this way, no? To balance that, this should give this way. Okay. Now this force will have along this direction a component here, this way. This force at this joint B acts a force this way. To balance that, there should be a force here. The tension there. Here, this force gives to the joint D this way force. To balance that, we need the force this. This. Right. Now, you can complete this. Everything you know. So then, there are 5 rods, no? 5, 5, 5, 25 marks come in here. Right? 5 plus, 5 plus, and so on. Right? Okay. That way, complete the table. The rest also you know. Right? Okay. That's the end of the discussion of paper number 8. This time we took more time to discuss. Because the questions a little bit long.